Good day. So we're going to deal with sigma notation from different past papers. As you can see, this one is November 2020, 3.1. So November 2020, 3.1 says, prove that this is a convergent geometric series. So what is a convergent series? A convergent series is where the common ratio is between -1 and 1, meaning that the common ratio must be a negative or positive proper fraction. For instance, if r is -1/2, then the series will become convergent, meaning that it has a sum to infinity. So it has a sum to infinity. There's a video where I deal with convergence and divergence. Here I'm just briefly explaining. So if r is -1/2, it means that it is a proper fraction, right? It means it falls in this range. If r is, let's just say, -3/2, well, it doesn't fall into this range because 3/2, if you check it in the calculator, it will give you -1.5, and -1.5 is smaller than 1, so it doesn't fall into this range, and it's an improper fraction. Just to wrap up, a proper fraction is where the numerator is smaller than the denominator, and an improper fraction is where the numerator is bigger than the denominator, right? So if r is equals to 2, it doesn't fall into this range. The series is not convergent. It doesn't fall into this range because 2 is not into this range, and 2 is an improper fraction. If you check it, 2 is the same as 2/1, right? So it's an improper fraction. So it must be a proper fraction for it to be convergent. It must be a negative or positive proper fraction. R must be in this range. So in this case, we just have to prove that the common ratio will be in this range. If we prove that the common ratio is in this range, then we have proven that it's convergent. All right, let's continue. Let's go. So when we say sigma notation, we obviously know how it's done, right? We always find the first 3 terms and the last terms. So let's substitute. So it's starting from 1, so meaning that you have to put 1 there. So it's going to be 4 times 3, 2 minus 1, to the power of 2 minus 1, plus 4 times 3 to the power of 2 minus 2, plus 4 times 3 to the power of 2 minus 3, plus ... Well, the last value is infinity, so it continues, right? So we just leave it like that. If you just see a sequence continuing like that, it just means it continues infinitely, right? So there is no end to it. So this value 2 minus 1 is 1, so 4 times 3 is 12, plus here 2 minus 2 is 0, 3 to the power of 0 is 1, anything to the power of 0 is 1, right? So 4 times 1 will be 1. Besides, if you just type the whole thing in the calculator, you will get it. And then now 2 minus 3 is -1, so 3 to the power of -1 is 1/3 times 4 is 4/3, plus ... So now let's find the common ratio, right? So notice, sigma notation will always form the first 3 terms using this stuff. So let's find the common ratio. Well, it's not tough to find the common ratio. This divided by this, so it becomes 4/12, right? 4/12 is equals to 1/3. Similarly, so it means r is equals to 1/3. Similarly, if you divide this by this, 4/3 divided by 4, you will see you will definitely get 1/3. So the common ratio is 1/3, and 1/3 is within this range. So now you will tell them that r is equals to 1/3, and 1/3 is between -1 and 1. Then you will say, therefore, the series converges. So therefore, the series, don't mind my handwriting, I'm just writing roughly just to give you an idea of how to write converges, right? So converges. So that's what you will tell them. You'll say, therefore, the series converges. Why not sequence? Sequence is when we put commas between. Series is when we put addition between. So we could have put commas here, and we could have put commas. We could have put commas everywhere. But a series is when we add them, right? So, and why should it be a series and not a sequence? It's because it's sigma notation. Sigma notation means summation, right? It stands for summation, meaning that we have to find the sum, which is addition, right? Difference is subtraction, sum is addition, product is multiplication, and quotient is division, right? These are the basic words, mathematical languages. So sigma is summation, which is addition. So that's why we put pluses between this stuff and not commas as before. So whenever we put commas, it's called a sequence, but whenever we put addition signs, it's called a series. Then the next question says, which is 3.2, so the next question says, if the sum to infinity is equals to 2 over 9, determine the value of p, which is the starting point. So of course, when we see sigma notation, we always do what we do from the first three terms. So this becomes 4 times 3 to the power of 2 minus p, right? Plus 4 times 3 to the power of 2 minus, what is after p is just p plus 1, so minus p plus 1. It's better to put it in brackets. It's actually best to put it in brackets. If you don't put it in brackets, you will get it wrong because of the value. Alright, and then the next one, what is after p plus 1 is p plus 2, right? So this is mathematical language. You are probably seeing this for the first time, so just put it as part of your skills. Whenever they start with a letter, the next one will just become that letter plus 1, the following one, that letter plus 2, plus dot dot dot, remember it's infinitely. So we know that S infinity is equals to a over 1 minus r. And we did get our r before. Our r was 1/3, right? So our r is 1/3. So it means our sum to infinity, which is 2 over 9, is equals to our a. Our a is that stuff, which is 4 times 3 to the power of 2 minus p over 1 minus 1/3, right? And then from here, when we continue, it means 2 over 9 is equals to 4 times 3 to the power of 2 minus p all over 1 minus 1/3 is 2/3. And then now here you have to use the cross multiplying stuff. So it becomes 2 over 9 times 2/3 is equals to 4 times 3 to the power of 2 minus p, Alright, then from here this becomes 4 over 27 is equals to 4 times 3 to the power of 2 minus p. And then when you divide, because we're solving for p, so let's divide both sides by 4. When you divide both sides by 4, you will get 1 over 27 is equals to 3 to the power of 2 minus p. And then what happens here? 27 is the same as 1 over 3 cubed. Okay, it's the same as 1 over 3 cubed, which is equals to 3 to the power of 2 minus p. And then this is exactly the same as 3 to the power of negative 3 equals to 3 to the power of 2 minus p. And then from here, so here it was 1 over 3 cubed, right? Remember 1 over 27, this just became 3 cubed. When you break it down, it's 3 cubed. And then this becomes that. So now since the bases are the same, we can equate the exponents. So minus 3 is the same as 2 minus p. Let's take p that side. And then let's take minus 3 to the other side so that it can become 2 plus 3. And p becomes 5. And there we have it. We have solved for p.